All right, guys, so just like everything else that we've covered in Chapter 5, this is 5.5. We're talking about permutations and combinations. And again, like everything else we've kind of covered, you may have seen a lot of this already, depending on your teacher and the time frame and when this was learned, and this may be brand new to you. So I've got a question posted right here. It says, consider the number of permutations of the letters in the word July. In how many ways can you arrange all of the letters, and in how many ways can you arrange two of the letters? So what it means by permutations. A permutation, again, if you haven't seen that before, the definition's right here, and it's kind of an important one for you to have because we need to be able to tell the difference between permutation and combination. So a permutation is an arrangement of objects where the order of the object matters. Okay, so for example, if I had 3 people and I was trying to pick a president and a vice president and a secretary, the order that I pick them matters, right? Because let's say that we make Sally the president, and we make Joe the vice president, and we make Peter the secretary. That is different than if I make Joe the president and Sally the vice president and Peter the secretary, right? Those are different arrangements. It's the same people, it's the same objects, but they're in a different arrangement, and the order of this arrangement matters, okay? So it's asking me to consider the number of permutations of the letters of the word July. So what it means by that is July is one permutation. That's one way I can put them in order. I could also go backwards, YLUJ. I could also do U first, and then Y, and then J, and then L. These are all called permutations. And the question is, how many different permutations are there? Nice thing about permutations, it's really easy to do. First, what I'm going to do is look at how many things I'm picking. So in the word July, there's 4 letters. So to figure out the number of permutations, I take 4 for the first letter. That's how many choices I can pick for the first letter, right? The second letter, I've already picked one of them, so there's only 3 left to choose. The third letter, I've already picked 2 of them, so there's only 2 left. And for the last letter, I've picked the other 3, so there's only 1 left. And if I multiply those numbers together, 4 times 3 times 2 times 1, 4 times 3 is 12, times 2 is 24, times 1 is 24. So there's 24 different permutations if I am organizing the letters of the word July. All right, let's look at another one. In how many ways can you arrange... Oh, you know what? There was a second part to that question, wasn't there? It says, what if I'm only arranging 2 of the letters? Not all of them. What if I just want 2 of the letters arranged? In that case, if I have 4 letters total, but I'm only choosing 2 of them, right? So my first choice, there's 4 letters that I could choose from. My second letter, there's only 3 left to choose from. So I do 4 times 3, which means if I'm only picking 2 letters, there's 12 different permutations. All right, pretty easy math. In how many ways can you arrange the letters in the word house? Well, there's 1, 2, 3, 4, 5 letters in the word house. So I'm going to do 5 times 4 times 3 times 2 times 1, which ends up being 120, I think, if you multiply those together. In how many ways can you arrange 3 of the letters in the word March? So in the word March, there's 1 letter, there's 2, 3, 4, there's 5 different letters. I only want to arrange 3 of them, not all 5. So my first letter could be one of the 5 choices. My second letter, there's only 4 letters left to choose. The third letter, there's 3 letters left to choose. And I can stop right there because I'm only arranging 3 of them. So 5 times 4 is 20, times 3 is 60. So there's 60 different ways you could arrange 3 of the letters in the word March. All right. Getting into problems that are maybe not so easy to just multiply and count. Same idea. We have a formula that we can use to find permutations. And the formula is right up here. And we're going to ignore this. We're going to ignore this. In fact, we're going to ignore even this part, okay? The number of permutations, all you need to know is this piece of the equation, NPR. Okay, so we're going to focus on little n, big P, little r. This is a button on your calculator that will tell you the number of permutations, all right? Now, P stands for permutations. So the P is always there. You don't change the P. But N and R are 2 different numbers that you need to know. So N stands for the total number of choices, like 5 letters, 10 letters, 11 letters, 5 people, 20 people. It's the total number of objects that you're choosing from. So maybe we should rewrite that. The total number of objects that you're choosing from. Okay. R is how many you are choosing. All right. R represents how many you're choosing. So in the problem that we did earlier, we did 2 different permutations with the word July. The first one, it was to pick how many permutations if you used all of the letters. So that would look like this. There's 4 total letters. I want a permutation, and I'm going to choose all 4 letters. N represents how many to choose from. In the first case, we wanted all 4. The second time, it only wanted me to pick 2. So this would look like out of 4 letters, I'm going to permutate 2 of them. I'm only going to choose 2, not all 4 of them. All right. So let's look at a problem. 10 horses are running in a race. In how many different ways can the horse finish first, second, and third? All right. So all we're interested in, we're not looking at all 10 positions. We just want first place, second place, and third place. So I'm only picking 3. I'm only going to pick 3, and I have a total of 10 horses. So what that looks like in my formula is out of 10 horses, I'm going to permutate 3 of them, right? Because the order does matter. First, second, and third are different places, so the order that they come in matters. Now, on your calculator, there's a button that looks like this, NPR. Every calculator that we use in this class has it. The black calculator, there's a button that looks like this. It has an exclamation point, and then it says NCR and NPR. All right, the first time you click it, you're going to get an exclamation point. If you click it again, you'll get NCR. If you click it a third time, it changes to NPR. All right, if you're using the white calculator, let me get rid of some of this. If you're using the white calculator, there's a button that says where'd my pen go? PRB. That's a button on the calculator. When you hit that button, a menu pulls up, and the first option says NPR, and that's what you would choose. So the way that you put it in the calculator, before you hit the NPR button, you put whatever number is your N. So in this case, I would type in my calculator 10. Then I'm going to hit the NPR button, wherever it is on my calculator. And then after NPR, you're going to put how many you're choosing, the R value. And in this case, it would be 3. So I would do 10 NPR 3. And if you do it correctly, I haven't even done this one yet. If I do 10 NPR 3, you get 720 different permutations. That's how many different ways the horses could win first, second, and third. There's 720 different possible results. All right, so on your homework, I want you to try, this is homework 5.5, I want you to try 3 through 15 and 17 through 18. I want you to focus on this NPR button, okay? If you can't figure out how to make it work on your calculator, come see me. I'll help you figure out how to get the button to work.